For lesson number 5 is a difference of squares. It's a specific type of trinomial factoring. So we're going to start off with the following. I'll just review from kind of what we did yesterday. It says complete the following using the trinomial factoring method from the previous lesson. So my polynomial is x squared minus 6x minus 16. What I need to find is I need to find two integers that have a sum of negative 6 and a product of negative 16. So my two numbers would be 8 and 2. 8 times 2 is 16. If I make my 8 negative, there's my negative 16, and my sum becomes negative 8, because negative 8 plus 2 is negative 6. So then my factored form, I use these integers, and I get an x minus 8 and an x plus 2. So if I look at the next one, I need two numbers that multiply to give me negative 16 and add to give me negative 15. So from yesterday, the one thing that we did realize is in order to get a negative 16, one of the numbers has to be positive, one has to be negative, which then means when I take my two integers, I'd find the difference to get my 16. So two numbers where the difference is equal to 15 would be 16 and 1. And if I want to make that a negative 15, I make this a negative 16. So when I go to factor this, I will get x squared, or sorry, not x squared. I will get x minus 16 and x plus 1. My polynomial, the sum becomes the middle term. The product is the last term. And the first term is my x squared. So now if we look at question 3. I have a polynomial where the middle term is actually equal to 0. So instead of writing this as x squared plus 0 x's minus 16, I can write it as x squared minus 16. In terms of my sum and product chart, I'm looking for two numbers that have a product of negative 16, but the sum is equal to 0. Four and negative 4. So when I go to factor this, I get an x plus 4 and an x minus 4. So if I look at the next one, again I have a sum of 0. So I have x squared plus 0x minus 64, or in simplified terms, x squared minus 64. And then the last one would actually be an x squared minus 25. So I want you to take a moment and fill in these two rows telling me, or showing, I guess, on your page, what two numbers give me a sum of 0 and a product of negative 64, and then what two numbers give me a sum of 0 and a product of negative 25. So pause, finish it up, and then you can press play again. So the two numbers for row 4 would be a positive 8 and a negative 8, which would give me x plus 8 and x minus 8 in factored form. And then the last one would be negative 5 and positive 5, or positive 5 and negative 5. Order is not important. So I'd get an x minus 5 and an x plus 5 for my factored form. So if we look at the pattern of these last three rows, the factored form of x squared minus 16 is x minus 4 and x plus 4, or x plus 4 times x minus 4. The factored form of x squared minus 64 is x plus 8 and x minus 8. The factored form of x squared minus 25 is x plus 5 and x minus 5. What pattern do you see? What I want you to do right now, if you see the pattern, pause and go through these 5. If you don't see the pattern, pause anyways and discuss with a friend as to what the pattern is and try to complete these 5. So now that you've taken time to go through these 5, what pattern did you see coming up? Well, square root of 16 is 4. Square root of 64, 8. Square root of 25, 5. And then I just make one positive and one negative. So if I look at x squared minus 9, square root of 9, 3. So I get an x minus 3 and an x plus 3. X squared minus 49. Square root of 49 is 7. X minus 7, x plus 7. X squared minus 36, x minus 6, x plus 6. X squared minus 1, x minus 1, x plus 1. And the last one, a squared minus 100, becomes a minus 10 and a plus 10. In all of these polynomials, if I went to expand them out, the first term would be x squared, x squared, x squared, x squared, a squared. The last term is the product of the last two terms in each binomial. Negative 9, negative 49, negative 36, negative 100, negative 1. And that middle term that I usually get from multiplying the outside and the inside terms cancels out each time. Positive 3x, negative 3x. Positive 7x, negative 7x. Positive 6x, negative 6x. Positive 1x, negative 1x. Positive 10a, negative 10a. So if I factor algebraically this m squared minus n squared, what did we do? Well, we took the square root of the first number. Square root of m squared is m. Then we took the square root of the last number, n and n. Made one negative and one positive. So that if I go to expand this out, I get m squared plus mn minus mn, because we put it in alphabetical order, minus n squared. These two terms equal 0. They cancel each other out, leaving me with m squared minus n squared. So if I consider the expansion x minus y plus x plus y, explain why the value of bx, when I go to expand it, equals 0. Well, if I show this in expanded form, x times x, x times y, negative y times x would be a negative xy, negative y times y would be a negative y squared. This would equal 0. So a positive xy minus an xy equals 0. And express c in terms of y. C is equal to negative y squared. This type of factoring and binomial operation is called a difference of squares. Difference because I have a minus. Minus is a difference. Squares because the first and the last term are squared numbers. So to give you a visual of what this looks like, if I had x plus 3 times x minus 3 with my algebra tiles, and I multiplied them together. So I've put in an array just so that I can see this is being multiplied by that. It's kind of like length times width. So x times x gives me my x squared. X times positive 1 gives me a positive x. And that happens 3 times. And then I have x times negative 1, so I get a negative x 3 times. Then I have negative 1 times positive 1, so I get a negative 1, and that occurs 9 times. So if I go to simplify this, my x's and my negative x's, so these 3 green rods and these 3 white rods are going to cancel each other out. And then what I have is if I take all of my negative ones and put them together, the shape that I'm left with is I'm left with a square. And if I put this, oh, just a second. If I overlap this, there's my difference of squares. And that's kind of what's shown on the previous page. There's my difference of squares. So my difference of squares in my length and width in terms of it, this piece in here is an A, and this piece in here becomes a length of A minus B, and then I have A plus B. So the shaded area ends up being A plus B times A minus B. So what you have to be able to do is recognize that this is a difference of squares. The key term being difference, so it has to be minus and squares, meaning it has to be a perfect squared number, which is that list of red numbers on the board. So a squared minus 4, it's a minus. That means it's a difference. Can I take the square root of a squared and of 4? The answer is yes. So I get an a plus 2 and an a minus 2. If I look at the next one, it is a difference. These two values, or these two terms, are perfect squares, meaning I can square root them. T minus 12, t plus 12. Doesn't matter if I put the t plus 12 first or second, it's still going to work. In C, we don't have any numbers, but we still follow the same format. This is a difference, and these are two squared numbers. So, square root of x squared is x, square root of y squared is y. And in the last one, I've got p squared minus 7 squared, which you want to rewrite it, becomes p squared minus 49, which when I factor it, p plus 7 and p minus 7. So I didn't actually even have to expand out or evaluate 7 squared. The 7 just goes to each part. Note, I cannot factor something like x squared plus 4 because x squared plus 4 is x squared plus 0x plus 4. So now you have to find two numbers that multiply to 4 and add to 0. Not possible. We don't have a method for doing that. In the identity, a squared minus b squared equals a minus b times a plus b. A and b could be numbers, they could be variables, they could be monomials, they could even be polynomials, which we'll look at next year. For example, 4x squared minus 25, the square root of 4x squared is 2x. The square root of 25 is 5. So I could rewrite this as 2x squared minus 5 squared. And then I could factor them with the idea that a would be 2x and b would be 5. And then one of these factors would be positive and one of these factors would be negative. Or 9m squared minus 4n squared. I could rewrite it. The square root of 9m squared is 3m squared. Square root of 4n squared is 2n squared. So again, I could factor this as a 3m plus 2n and a 3m minus 2n. We can verify these factors by expanding them out and seeing if we come up with the original polynomial. 3m times 3m is 9m squared. If I multiply the outside terms, I get a negative 6mn. The inside terms gives me a positive 6mn, so that canceled out. That left me with 0. And when I multiply the last terms, I get negative 4n squared. So what I would like you to do is I would like you to pause at this point, and I would like you to try to do class example number 2 on your own. And then when you're ready, you can press play and continue. So we are asked to factor, if possible, using the difference of squares method. So if I look at the first one, I square root the first and the last. So if I square root 16t, I get 4t. Square root 49 and I get 7. So I get 4t plus 7 and 4t minus 7. If I look at b, I want to make sure it's a difference, which it is, and then I look to see if the two terms are perfect squares, which they are. So 9a plus 1 and 9a minus 1. C is written backwards to how we usually see it, because we're used to seeing that variable first. But I still ask myself, is this a difference? Yes. Are these two terms perfect squares? Yes. So we take the square root of the first and the square root of the last. One's positive and one is negative. Don't rewrite it. Don't put it like this, because it's just going to be nasty to try to write it out. Leave it in the order that it's written. So if I do that with D, I would get 6p minus 5q and 6p plus 5q. When I take a look at E, remember the first step is to make sure it's a difference. This is not a difference. So this we write as being not possible using the difference of squares method. And now if I take a look at the last one, it's a difference. I can square root 64, I can square root 9, and I can also square root my a squared and my b squared. 8 minus 3ab and 8 plus 3ab. Class example number 3. The floor of an international double squash court is a rectangle that has an area of 25 a squared minus b squared feet. If I have to write expressions for the length and the width, it means if this is the area, factor it. So 2 factors. This is the difference of squares. So 5a plus b and 5a minus b. Let the length be 1 and the width be the other. The perimeter of the floor is 140 feet. Determine the length and the width if the length is 1.8 times the width. So, I have the perimeter of the floor is 140 feet. 2 times the length, so 2 of the lengths plus 2 of the widths equals 140. So I expand this out. 2 times 5a gives me 10a minus 2b plus 10a, this should be a plus 2b, minus 2b equals 140. The positive 2b and the negative 2b cancels, meaning it equals 0. 10a and 10a gives me 20a. It's 140. divide by 20, and A equals 7. The next part, determine the length and the width. If the length is 1.8 times the width. So the length, which was 5A plus B, is 1.8 times the width, which was 5A minus B. And I know that A is equal to 7. So I've got 5 times 7 plus B equals 1.8. Actually, let's remove the brackets first. 5A plus B equals 1.8 times 5 is 9. So I get 9A minus 1.8B. Now let A be equal to 7. And I get 35 plus B equals 63 minus 1.8B. I want to put the B's on the other side, or on one side, so I'm going to get rid of this negative 1.8 by adding 1.8 to each side. Okay, 35 plus 2.8B equals 63. Then I'll subtract 35 on each side. And I'll get 2.8B equals 63 minus 35 is 28. Divide by 2.8. And I get that B equals 10. So I now know the value of B, and I know the value of A, but I actually haven't answered the question yet, because the question asks what's the length and the width. So the length is 5A plus B. 5 times A plus B. A was 7, B was 10. 5 times 7 is 35, plus 10 is 45 feet. And then the width, 5 times 7 minus 10, which would be 25 feet. The perimeter, I have 90, and 50 would be 140. And if I take 25 and multiply it by 1.8, I do get 45. And the last example. If I look at class example 4A, 2A squared minus 50. Well, it's a minus, so it's a difference, but I can't square root these two numbers. However, the first thing that we should be doing when we go to factor is removing the greatest common factor. That should be our first step. So if I take a 2 out, I get A squared minus 25, which gives me an A plus 5 and an A minus 5. So again, what I'd like you to do is I'd like you to pause, try the next 3, and then when you're ready, you can continue playing. So if I look at B, it is a difference, but these are not square numbers, so I'm going to factor out a GCF, which is 3. And I get x squared minus 4y, which are now square numbers. I can work with this. So I get 3x plus 2y and x minus 2y. Now C is a tricky one. I'm actually going to skip it and I'm going to go to D first. So in D, I can factor out a 3x this time. And I get x squared minus 9. If I didn't factor out that x, I would have an x cubed minus 9x, which I wouldn't be able to then factor. So if I factor the x squared minus 9, x minus 3, x plus 3. So if we look at C, there are 2 ways we can approach C. The first way is following this first step. I can remove the GCF. If I remove the GCF of 4, what I end up getting is I get 36 p squared squared minus 1. These are perfect square numbers, which I can then factor. 6pq plus 1 and 6pq minus 1. That's one way that I can solve this. What makes this question tricky is when I look at 144 and 4, they're perfect square numbers. So I could square root them, in which case I would get this. But if you remember in the previous lesson when we were talking about what it means to factor, factor means to make sure that my factors are in simplest terms. So when I look at these factors, I should not be able to factor anything else. If I look at a 12 and a 2, I should realize that I can factor out a 2. If I factor out a 2, I get 6pq minus 1. Factor out another 2, and I get 6pq plus 1. These are all being multiplied together. 2 times this times 2 times this, which means I can put the 2 and the 2 in front, which gives me 4, and I am at the answer that I previously had, but it has taken me extra steps because I didn't factor out the GCF first. So it is very important to always look to see if I can factor out that common factor before I continue trying to factor the rest of the question. So the questions that I want you to work on, question 4, E, F, G, H, I, J, K, and L. Question number 5, question number 6, A, C, and E, 7, A, and C, and 12, 13, and 14.